Take a look at these questions side by side. Let's call them variant A and variant B. They're almost identical. Both are quadratics in the general form with one or two unknown constants. Both have at least one solution, and in both cases you're tasked with finding some maximum value related to the constants. The first question, variant A, is fairly straightforward if and only if you know the trick, which is to set the discriminant greater than or equal to 0. Simplifying the inequality brings us to the result that AC must be less than or equal to 7,744, so the greatest possible value of AC is, well, 7,744, which is pretty neat. However, if you try to apply this method to variant B, you run into a problem. After discarding the negative case, you're left with the statement that B must be at least 97.57. So you have a minimum value of B, but you know nothing about the maximum, which is what we're looking for. And that's because these problems are only superficially related. Variant B isn't about the discriminant at all. It's about combinatorics. To create your quadratic from two factors, your first terms need to multiply to give 34, and your last terms need to multiply to give 70. You can then calculate the value of B based on your initial assumptions. But this is just one possible value. Change your assumptions, and your B value changes too. Since there are 4 factors of 34 and 8 factors of 70, there are 32 possible permutations. But half of these are reflections of the other half, so there really are only 16 combinations to test out. And the largest of these will result in a B value of 2,381.